All right, so we're talking proportional relationship tables. So, rate of change. The rate of change describes how one quantity changes in relationship to other quantity. In a proportional relationship, the rate of change is equal to the constant of proportionality. So, what does that mean? That means that whatever my constant of proportionality is, my rate of change is that. So, when we always go back to our original equation, y equals mx plus b, whatever my K is going to be equal to my M. Why? Because the relationship is proportional. If I'm proportional, if I can find a constant rate of proportionality, I can always find what my slope is or my rate of change. So here, it gives us what our equation is. So if they give us a situation, we need to be able to fill in the table. And we need to identify what is the rate of change. If I know my equation, based on what it says here, my constant rate of change is always going to be what's part of my equation here. I can know my rate of change just from looking at the equation. Why? Because in our equation, I'll use a highlighter. Here, the 9.5. The 9.5 there lets me know that is my rate of change. That means it's always going to be changing by 9.5. Everything will be multiplied by 9.5 because that's the rate of change. So from the equation, I know that my rate of change is that. So what does that mean for my y? That just means I can multiply everything by that. So I can say 9.5 times 0, and I know that's 0. 9.5 times 1, and I know that's 9.5. And 9.5 times 2. Why? Because all of these numbers are being plugged into the x. And I'm just using the x numbers to be able to get the rest of my table. So then it'll be 19 and then 28.5. When they give you an equation, it's quite easy to identify what the rate of change, but you're not always going to be given that scenario. The other scenario will be what happens if they give me other information. So that's what we need to use. It says, as the x values increase by 2, the y values increase by 60. So they told me that my x is going up. So if I look at, remember, we're always looking at what's y over x. So even here, if we were filling in our table, if my x value increased by 2, my y would increase by 60. So I know 60 will be here. I can utilize this value here to identify what is my rate of change. So 60 divided by 2 is 30. That means that if my rate of change is 30, my equation then is y equals 30x. So every time I plug in an x in here and multiply it, I'm going to be able to fill in the rest of my table. So at 1, I know it's 30. At 3, I know it's 90. And at 4, it'll be 120. If I'm going too fast, please speak up. If there's any confusion, speak up. One thing about proportional relationships, they're probably the easiest part of linear relationships. Our difficulty will come in when we learn about when it's non-proportional. So really, every day this week is just reiterating the fact that you know to divide or to multiply. All right, so we're going to use our knowledge to answer these questions here. So Camping Craze hires a graphic designer to create a new logo and marketing materials. The graphic designer charges Camping Craze $45 per hour. Per is a key word here because what does per mean? And what does every mean? What mathematical operation is happening here? Multiplication. So if I know per, every, each means I'm multiplying, that lets me know that whatever it's referring to is going to be attached to the x. Why? Because of what we found in our equation was anytime I know my rate of change, I know I was multiplying by x. So here, when I think of what will my equation be here, I had to think about that. They're saying they're charging $45 per hour. In math, that just means they're saying y equals 45x. That's all they're saying because they use the word per, every, or each. Whenever we use a word that means to multiply, that's telling me I'm multiplying by some level of an x value. So my x has to be talking about hours. So I know whatever my hours are is going to be, and then my charge will be whatever my y is. So this has to be the x value, the number of hours. So I know if it's 1, 2, 3, 4, 5, and this is my y. This is my output because our y is always going to be our output, and x will be our input. So if I know I'm always going to input an x and my output or my outcome is my y, then this makes a little more sense. Because if I put in 1 hour of work, I know I'm only going to be charged $45. If I put in 2 hours of work, my output is $90, and on and on. So it says find the rate of change. Well, we identified that. That's 45. What does the rate of change represent in context of the situation? It represents that the total cost for the graphic designer will increase by $45. So we know that there's going to be an increase by $45 every hour. We know this is an increase because this is a positive number. There's times when there's a decrease situation and we'll use a negative number. And then we can, of course, fill in the paper. It says, write an equation to show the relationship between x, the number of hours, and y, the total cost. We already wrote our equation, y equals 45x. And then we can definitely fill in the rest of our table. I'm going to flip the page now. Let's see. So if we can utilize some board time here, just to ensure that we